Hello everyone, welcome back to Network Mailam. Today we are going to understand IPS architecture and the pre-processing pipeline in a very simple way. By the end of the class, you will clearly understand what happens inside an IPS before it blocks an attack. IPS architecture means the structure or design of an IPS system. IPS is not just one device. It has multiple components working together, like sensor, pre-processing system, detection engines, management console, logging system. All these parts together protect the network. Let's understand the simple flow. When traffic enters, traffic, then it is go to sensor, then pre-processing, then detection, then decision, then logging, then allow or block. The entire process happens in milliseconds. Sensor. The sensor is the heart of the IPS. All traffic passes through it. It captures packets, inspects them, and decides whether they are safe or dangerous. Example setup. Internet, firewall to IPS, then IPS to internal network. If something malicious comes, the sensor blocks it immediately. Before IPS checks for attacks, it must prepare the traffic. This preparation stage is called pre-processing. Think of it like organizing files before checking them. When traffic enters IPS, the first step is packet capture. IPS receives the packet and separates header and payload. Now the packet is ready for deeper inspection. Headers contain IP address, ports, and protocols. Payload is the actual data. Step 2. Packet normalization. Attackers sometimes send unusual or malformed packets to bypass detection. Normalization means IPS corrects and standardizes packet format. This prevents attacks from hiding malicious content. It's like cleaning messy handwriting before reading it. Fragment reassembly. Sometimes packets are broken into smaller fragments. This is normal in networking, but attackers may hide malicious code across fragments. IPS collects all fragments and rebuild the original full packet before checking it. This step is very important for security. TCP stream reconstruction. Data does not always come in one packet. It comes as multiple packets over time. IPS rebuilds the full communication session. Why? Because attacks like SQL injection may be spread across multiple packets. IPS read the full conversation, not just one message. Protocol decoding. IPS identifies which protocols is being used. For example, HTTP, HTTPS, FTP, DNS. Each protocol needs different inspection rule. So IPS decodes the protocol properly before detection. SSL inspection. Most internet traffic today is encrypted. If SSL inspection is enabled, IPS decrypts the traffic, inspects it, encrypts it again. This requires more processing power. Detection engines. After pre-processing is completed, traffic goes to detection engine. This is where actual attack detection happens. Signature-based detection. This engine compares traffic with known attack patterns. If a match is found, traffic is blocked. It works very well for known threats. Anomaly-based detection. This engine detects unusual behavior. If a user suddenly sends thousands of requests, IPS flags it as suspicious. This helps detect new or unknown attacks. Signature database. IPS needs regular updates. New attacks comes daily. Without updating signature, IPS cannot detect new threats. Management console. In companies, administrators use a management console to add rules, update signature, monitor alerts, generate reports. It acts like a control center. Logging and monitoring. When IPS blocks something, it creates a log. The log includes source IP, destination IP, attack type, time, action taken. These logs are sent to SIM tools like Splunk, IPM QRadar, SOC team monitor these alerts. Type of IPS. There are two main types, network based IPS and host based IPS. Network based IPS protects the entire network. A host based IPS installed on individual system. In real companies, IPS is placed after the firewall. Firewall removes basic unwanted traffic. IPS deeply inspect allowed traffic. Performance and availability. IPS efficiency and network speed it depends on below factors, which is throughput, latency, rule tuning, SSL inspection. Companies also use backup IPS to avoid downtime. High availability. So there is a two method which is active active and active passive. In active active, both IPS should work, but in active passive, it is the primary and secondary method. Primary is in active and secondary is in standby. When the primary is failover, that time the secondary will take over the traffic. And what is fail open config? If by the IPS power fail happens, that time the entire traffic IPS will bypass. Okay, it is prioritizing the network connectivity over the security. They sequence data flow before it reaches the detection logic. So first it goes to packet capture, then normalization, then fragment reassembly, then TCP stream, then protocol decoding, then an SSL inspection. Today, we learned IPS architectures includes sensor, preprocessing pipeline, detection engine, signature database, management console, logging system. All this work together to stop attacks. Which pre-processing step do you think is most important? Fragment reassembly, TCP reconstruction, or protocol decoding? Comment below. We'll see you in next video.